Hey guys, I'm Pat Kelly. Okay, in this problem, you can see they've given us some information on two vectors, u and v, and the information for each is just the initial point and the terminal point. And the directions ask us to determine if these two vectors are equivalent. All right, now my thought process here is that vectors, you know, have magnitude and they have direction. So what we need to do is check to see if these two vectors have the same magnitude, and if they do, then do they also have the same direction? If we get two answers of yes, then the overall answer is yes. So let's see. I'm going to find the magnitude of my first vector, u, which, this is what we're practicing, is how do you find magnitude? It's the square root of, and then what I do is I'm taking my first coordinate, the x-coordinate of each of these points, and subtracting them from each other. So minus 1, subtract the 2. But then you square that and add the subtraction of the corresponding y-coordinates. So 4, subtract those corresponding y-coordinates, 4 minus 2, and then squared. And that's all under my radical hat. So this looks like it's going to be the square root of minus 3 squared is 9 plus 4 minus 2 is 2, but squared is 4. And I'm getting an answer of the square root of 13, which I don't need simplified at all or decimal equivalent. I'm good to go. Because all I really want to do is compare that to the magnitude of v. So I'll do the same work, but for the v vector, minus 5, subtracting a negative 3, squaring that, plus the 2, subtract the negative 1, that'll be plus 1, squared, close that radical hat, and now do some arithmetic, square root. Negative 5 plus 3 looks like a negative 2, but squared goes to 4, plus 2 plus 1 is 3, but square that, we get 9. And what do you know? Got the same answer of the square root of 13 as we got a minute ago, which tells me these two vectors have the same magnitude. That's only one criterion. We also have to check their directions. Now, if I'm going to check the directions here, this goes back to age-old algebra. You do slope, right? So rise over run. For my u variable, my rise, difference of the y values, 4 minus 2. It's my numerator, that's my rise, divided by my run, which is the difference of the x values. So minus 1, subtract 2. Subtract 2. Let's do the arithmetic there, and I get 4 minus 2 is 2. Minus 1 minus 2 is a negative 3. I'll put a minus sign in front of the fraction. That slope represents the direction of my first vector. Now I'll do the same work for the second vector. Maybe I'll even switch colors here for you, because now I'm looking at the initial and terminal point of vector v and doing that same kind of slope calculation. 2 minus a negative 1 will be plus 1. It's my rise over run, which is going to be a minus 5. Subtract the minus 3, so that'll be plus 3. A little bit more arithmetic, we'll get a 3 divided by negative 5 plus 3 looks like a negative 2, and I'll write 2 and put the minus sign out in front. All right, now take a look. Don't be deceived. They're close. But these two slopes are not equal, okay? So my two vectors do not have the same direction. They are not equivalent. Let me write that as an answer. These two vectors are not equivalent. Okay? That's my problem. Go do some of your problems. All right?